Welcome back to Namaste Node.js. This is another advanced episode in this series, and in this video, we are going to dive deep into Google's V8 JavaScript engine. You know that Google's V8 JavaScript engine is a very core part of Node.js, isn't it? In the previous episodes, we have seen that how Node.js basically works behind the scenes, how when we give the code, how it works behind the scenes, how it is executed by Node.js. But in this episode, we are going to dive even more deeper. We are going to see that what is the V8 engine architecture, what happens when you give your code to V8 engine. So how V8 engine works behind the scenes internally, that is what we are going to see in this video. And trust me, this is again going to be very advanced. So I would request you to please listen to me very carefully. This is an advanced episode. You'll have to take down notes while you are watching this video. Get your notebook and pen with you if you don't have already, and then listen to each and every word carefully with utmost attention. Okay, so let us start the journey of diving deep into V8. Are you ready or not? I would want you to be super ready and super careful while listening everything, because this is going to be very amazing. Okay, so let's get started, my dear friends. So now let us start with what we already know, right? From the previous episodes, you already know that we have Node.js with us. What is Node.js? Can you answer it now? If you can't answer what is Node.js right now, then you should go back and watch this whole series once again, right from episode 1. Okay, but don't worry, I know that you all know what Node.js is, so let us just move ahead with it. So this is Node.js, and we already know that there are two major components inside Node.js, which is the Google's V8 engine and libuv. And you know how they work in parallel and how they work together to make our code run fast and in an amazing non-blocking fashion. We know that already, right, from the previous episodes. And we have also seen that, okay, these are not the only two things which Node.js has. Node.js has a lot of libraries, modules, and a lot of other things, right? There are so many more things which Node.js has behind the scenes. But today, in this episode, we are going to specifically dive deep and talk about this portion, the V8 JS engine of which is developed by Google and maintained by Google till date today. Okay, so let's just dive deep into it and see what happens inside it. This is again going to be an advanced episode, so let us just start, and I just want your attention before you start watching anything further. Okay, so let's get started, my dear friends. Now, let me just tell you that, okay, you write some piece of JavaScript code. Okay, let me just draw and show it to you. Suppose you write some piece of JavaScript code. Suppose this is the code that you wrote. Okay, so suppose this is the code that you wrote. Now what happens? This code is given to the V8 engine. Suppose this code is given to the V8 engine. Okay, so let me just suppose, okay, this is the V8 engine. Now your code is given to V8 engine. Now what happens behind the scenes is what we are going to see. So the code is, what happens is you give it a code and you get the result out of it, right? That code is basically executed. So what happens in between? I'll just show it to you in form of diagrams. So there are several stages. I can call it as stages, or I can call it as steps, that happens when you give your code to V8 engine. So the first step or the first stage is known as parsing. Okay. Now listen to me very carefully. The first step, suppose you gave the code to V8 engine. This is your V8 engine below the line. This is your V8 engine. Now the first step that happens is parsing. So you gave your code. Your code can have a lot of variables, variable declarations, function executions, and a lot of things are there in your code, right? So what happens to your code is, the first step that happens inside this parsing stage is, okay, let's call this as A. Okay, these are stages, right? Let's say, okay, this is stage 1 or stage A. Now the first step that happens is known as lexical analysis. Okay, so there is a lexical analysis that happens with your code. Okay, what do you mean by lexical analysis is, see, the code that you gave in, right? The code that you gave in goes over here and lexical analysis happens. What is lexical analysis? That means the code that you gave in is broken down into tokens. Okay, the code that you give is broken down into tokens. Okay, so this is known as lexical tokens. Now you might ask, Akshay, what is tokens? Right? What do you mean by token? So I'll tell you that, okay, suppose you have written var a is equals to 10. Okay, this is a normal variable declaration. So what will happen is your code is broken down into smaller pieces, right? Smaller pieces, like suppose, okay, one token can be var, one token can be a, one token can be equal to sign, one token can be your 10, value 10. So similarly, your code is like broken down into multiple tokens before the analysis started to happen, right? Basically, right? So basically it's like V8 engine just starts reading your code, and it cannot read the code line by line, right? It reads the code token by token. Okay, how the code is read? Token by token. And that happens in this step, which is known as lexical analysis, and it is also known as tokenization. Okay, tokenization. So note it down. This is lexical analysis and tokenization, where code is converted into small tokens, right? It is broken down into pieces. You can assume that, okay, the code that you write is broken down into very small pieces. Now what happens is, then happens the second step. What is the second step? That is known as syntax analysis. Okay, syntax analysis. Now this is an interesting step. I'll just show it to you. So in syntax analysis, what happens is the tokens that you have broken down your code into, suppose this is your code which is broken down into tokens. Okay, so that's a very poor diagram to represent tokens, but bear with me. So what happens is, in syntax analysis, a abstract syntax tree is developed, right? A AST is developed, a tree is developed. Okay, now I know that it might sound very complex. So basically your tokens are then converted into AST. Now what is AST? It is known as abstract, right? I know it's a very fancy name. I'll just show it to you. Syntax tree. Okay, abstract syntax tree. So this is your AST. So what happens is, in the second step, syntax analysis, what happens? Your tokens are converted to abstract syntax tree. Okay, and this step is basically known as parsing. Okay, you are just basically, this is also known as syntax parsing, syntax analysis, and majorly the whole step, right? All this whole stage is known as parsing because of this step, right? So basically, when parsing happens, your code is just passed into V8 engine. So parsing happens. The first step is lexical analysis, which is also known as tokenization. Then the second step is syntax analysis, which is known as parsing. So what happens is, your code is broken down into tokens in the first step. Then the tokens are converted into an abstract syntax tree. It is form of a tree. That is why it is known as abstract syntax tree. Right now, it is looking like a fancy tree or something, but let me actually show you what abstract syntax tree is, right? So let me just show it to you. Okay, so I already have an example for you. So suppose, see, there is a famous website which is known as astexplorer.net. So this website lets you see the abstract syntax tree, right? And trust me, let me tell you that, okay, nobody will tell you all this. This is something you have to go and explore. I was very curious. I was so curious to study Node.js and how V8 engine works behind the scenes. And then reading led me over here. And I found out an amazing website which basically translate your code into your AST, which is known as abstract syntax tree. Okay, so now this is the abstract syntax tree, and you can feel this, you can see this website. It is known as AST Explorer, right? So suppose if you give it some code, right? This is var name is equals to namaste node.js. So what happens is, and this is the function. So what happens is, this code is broken down into tokens, right? This code is broken down into tokens, and then the AST is formed. And what is this AST? This is the AST that you see on the right hand side. So basically all the code that you write is broken down into and built, AST is built. Now you see it. All the code, see, you have just written these 3-4 lines of code, and this 3-4 lines of code has become so big, right? This is the AST. So what is this AST? See, It's a program, type program, and then if you'll just go and explore this website, right? It is very fun to see, right? And if you go and see this name, so it says that, okay, there is a identifier. And what is the identifier? So basically identifier is known as label, right? Basically, suppose, let me just tell you that what happens is a little bit of it. See, it's a very complex topic. I am just trying to explain you as easy, in a very easy language as possible, right? Because this is very complex in itself, right? How AST is developed, what are all these pieces in there. And let me tell you that, okay, even if you don't know any of it, still you can write Node.js code. But what makes you a great developer and an interesting, a curious and amazing developer is that you know behind the scenes. So I'm just planting a seed of curiosity in your head, my dear friends, okay? I'm not explaining you like 100% of everything, but I'm trying to just making you curious that, okay, there are so many amazing things that are happening behind the scenes. Okay? So what I'm trying to say is, when you give this code, this AST is formed. And in this AST, you will see whenever you are declaring any variable, right? So this line, basically line number 3, is basically declaring a variable which is known as name, and there is a value. So what happens is, if you will see clearly, so see, in the body of the program, you will find variable declaration. Basically, this means that, okay, the first line represent variable declaration. Now what happens inside variable declaration? There is a identifier, right? There is an identifier. Where is that identifier? If you click on this is the identifier. Basically, now so let me just explain you in a layman language that, see, whenever the JavaScript engine, V8 engine, sees that, okay, there is a var written, var written, var. So that means now it says, okay, this is a variable declaration. Now, whenever there is a variable declaration, there should be a identifier. What is identifier? Identifier is the name that you give to that variable, right? And the name is name over here, okay? So if you call it something else, okay, let's call it as x, okay? So this is a variable x, that means the identifier is x, right? So it creates a object like this identifier, and it also, right, see, this start and end is something which is managed by, like, this is managed by V8, and it's their internal notation. You don't have to know about that, but see this. So it says that, okay, this is type of an identifier and it is known as x. Now, how this Namaste Node.js, the value is stored, it is known as a literal. So if you will see this is the literal. If you will click on this, so it says that this is a literal. So basically, if you will see clearly, right, so whenever you declare a variable, it has two things. There is a variable declarator has two things. One is the identifier and one is the literal. So basically, where x is equals to Namaste Node.js is converted to this kind of an object, right? This kind of an object which has a declaration, it has an identifier, and it has a init literal, right? Basically the initialization, the literal, and this literal is what? Namaste Node.js. Got it? So this is how the whole AST is formed. Now in the diagram, I am just showing it to you in a fancy way, but this is kind of a tree structure, right? If you will draw it, right, it looks like a tree structure. So that is why, and if you will make it more complex, right, try to play with it, right? I'm not doing it right away. Just try to see that, okay, how functions are stored, right? How functions are converted to AST. It's a very amazing thing in itself. I would definitely suggest you go to this website astexplorer.net and just go ahead, write some code over here, write some JavaScript code, and just see how things are working, right? How these code are built, right? How basically a tree is built. So, and how you have to do it, let me give you a demo over here, right? So clear everything over here. Whenever you will write, suppose you wrote var x. Okay, so now see what is the AST which is being generated. So see, a variable declaration, and there is a declaration, and this declarator has a identifier, and this identifier is x. That's all. And we have not initialized it. The initial value is null over here, isn't it? The initial value is null over here. As soon as I write equal to and some value, let's suppose if I write equal to, now see, there is an error. There is an error in our program. That is why it is giving me an error, unexpected token, right? Basically, it is not able to see. See, when JavaScript V8 engine is reading your code, it reads token by token. Okay. So now, if there is an unexpected token which is found, right? What is that unexpected token? JavaScript was expecting something after that equal to sign, right? We don't have it. That is why this is a syntax error. This is a syntax error. So what do you mean by a syntax error? Do you know? Today I will tell you that why it is known as a syntax error. Why it is known as a syntax error? Because it is not able to generate an abstract syntax tree. When your code's abstract syntax tree cannot be generated, it throws a syntax error. This is your syntax error. Right? And now if I write 10 over here, so it generates your AST, and this AST now has a literal with the value 10 over here. Got it? So this is how code works. Try to write some code over here, play with that, and you will be amazed how V8 engine is just breaking it down into this kind of a tree. It's a tree data structure. That is why it is known as an abstract syntax tree. You can go and see the JSON version also. So this is kind of like a JSON thing, right? So in the JSON, it's kind of like a tree. And if we'll make it more complex, right? Suppose if there is a function inside a function inside a function, then what will happen is this tree will grow even further, right? This tree will become very complex, right? It can grow very complex. See, just one line of code is generating 34 lines of a tree. Think about like 100 lines of code. Suppose if you give it 100 lines of code, the tree will become very, very, very huge, right? That tree will become very huge. Okay, so this is what I want to say. And you know what? Try to give it a bigger program and then see how the tree looks. It will look very amazing. Okay. So this is what I wanted to say. Let me just move ahead now. So let me recap the parsing phase once again. So whenever you give any piece of code to JavaScript V8 engine, it goes through the first stage, which is known as parsing state. The parsing stage itself first do the lexical analysis. Code is broken down into tokens. Now this token is now what happens is syntax analysis happens of this token. Now this token is converted to a AST, right? What is an AST? Remember this is known as abstract syntax tree, right? In this step, and this abstract syntax tree is made. Okay, till now you understood, right? Let us just move ahead now. Once you have generated the AST, right? Once we have generated this AST, now we move on to, right? Now we move on to another step. Okay. I am just denoting it by a tree so that you remember it. This is your AST. Now we give this AST to an interpreter. Okay. It goes to the second step, which is known as interpreter. Interpreter. Now, before moving on to interpreter or something, right? Interpreter or something, before telling you what is an interpreter, what is a compiler, let me first of all ask you a very important question. Now, a lot of people ask, get this question in their interview: is JavaScript a interpreted language or a compiled language? Tell me. It's a very famous question. Is JavaScript an interpreted language or a compiled language? And first of all, even going before that, what is an interpreted language? What is a compiled language? What does it actually means? Right? What it means to be interpreted, what it means to be compiled. What does it mean? Right? So just think about it once, right? What does it actually mean to be interpreted or compiled? Tell me. Right? Do you know that? Okay, let me just tell you, if you know it, it's okay. If you don't know it, then it's also okay. See, now let me tell you that there are two types of languages. Two types of languages, right? Languages. And the first one are interpreted languages. Interpreted languages. The other types are compiled languages. Okay. Now, what is the difference between the two? How the code is executed in both of these languages. Now let me tell you that in the interpreted languages, there is an interpreter which reads the code line by line, right? As soon as you give it the code, it just starts reading the code line by line. Okay, as soon as you give the code to an interpreter or the interpreted language, it just starts to read the code line by line. It interprets the line and then executes it. It goes to the second line, executes it. It goes to the third line, executes it. Right? So what happens? It happens line by line. Okay, now what happens in compiled languages? In compiled languages, first the compilation, as soon as the code is given, first step is compilation. So basically what happens is, as soon as you give it the code, the whole code is compiled first of all into machine code. Your code is converted, your high level code is converted into your machine code. Okay, note it down in your notebook. Okay, machine code, and then the machine code is executed. So there is a difference. See this, as soon as you give it to, in case of interpreted languages, the code is given and then one by one it starts execution. Right? What happens in compiled languages? The whole compilation is done of the whole code. It is converted and translated into machine code, and then machine code is run. So what happens is, there are both pros and cons of both the languages, right? There are pros and cons of both the languages. But if you have to compare slightly, right? I'm not going and diving deep into each one of it, but I'm just telling you easier differences. Okay, I'll just tell you that. Okay, initially, interpreted language, fast initial execution, right? But what happens is, in the compiled language, initially heavy, but later fast, but executed fast. Okay, so there are different type of languages out there. In the compiled language, first of all, the whole code is like compiled into machine code, and that machine code runs very fast. Okay, similarly, you might have seen that, okay, there are languages like Java, where you have to, you give it Java code, then whole Java code needs to be built, right? The bundle is built. Now when you get that machine code, then you execute it, right? That takes an initial load. But there are interpreted languages, you give it and the code is run line by line, and it runs in a very initially fast manner, right? That's how. And over here the interpreter works. There is an interpreter which interprets the language and goes line by line. Interpreter, right? And over here we have compilers. Okay, so it's very easy. Interpreted languages, interpreter is there. In compiled languages, compiler is there. What is JavaScript now? Tell me. Is it an interpreted language or a compiled language? Amazing question, right? A lot of you might be thinking JavaScript is an interpreted language because the code runs line by line, isn't it? The code runs line by line. This is what you must be thinking. But let me tell you, my dear friends, out of these two types of languages, there is a third type also. The third type of language is JavaScript. I told you that JavaScript is very, very unique as a language. It does not work in a normal way. So what do I mean by that is that JavaScript is not an interpreted language, not a compiled language. JavaScript uses an interpreter plus compiler to work. JavaScript engine, V8 engine has an interpreter. It also has a compiler. It compiles also and it interprets also. Both of these things are there in JavaScript, and the compilation method in JavaScript is known as JIT compilation. JIT compilation. And what does it mean is just in time compilation. Just in time compilation. So JavaScript says that, okay, I am not interpreted, I am not compiled, I am a just in time compiled. Right? Amazing, right? What is just in time compiled? So there are many languages which are interpreted, purely interpreted, right? And those languages are people call them slow, right? Because interpreted languages are slow. Compiled languages take a lot of initial time to compile, but they are fast later on. Okay, but JavaScript is a mix of both worlds, which is known as just-in-time compilation, JIT compilation. Okay, now let me just show it to you how things work. till now we have, I think I have diverted from the topic, but what we were studying was we had this AST. Now what happens is this code is given to an interpreter. So now you understood, right? What is interpreter? Interpreter is basically the interpreter which is reading the code line by line, right, and executing it. So how does things happen inside? And I also told you in JavaScript there is an interpreter, there is a compiler also. Now let me just show it to you what happens. After you have this AST, you give it to interpreter, what happens? Let me just show it to you. Let me create a new page for now. Okay, I have a new page. So now we have this AST, right? And this AST is passed into an interpreter, right? Let me use another color to represent an interpreter. The name of the interpreter in Google's V8 engine is Ignition Interpreter. Okay, trust me, Google's V8 engine has such cool names of their interpreter and compiler. I just love it, right? This interpreter is known as Ignition Interpreter, right? Some sort of a, suppose it's an engine, right? V8 engine, and you ignite it, right? So that's how it has a ignition interpreter. Okay, so ignition interpreter. Okay, so we have this ignition interpreter. AST is passed into that ignition interpreter. Now the job of this ignition interpreter is to convert your code to bytecode, isn't it? Bytecode. So what happens is your code is basically taken, not the code basically. You take an AST, right? You give it an AST, abstract syntax tree. Now that abstract syntax tree is read by ignition interpreter and it is converted to bytecode. And once we have converted this AST to bytecode, finally what happens is execution happens. Execution of code, right? Basically your code is executed, right? This execution happens, right? What do you mean by execution? Basically whatever it needs to do. The bytecode is then executed in its own fashion, right? Now, whatever I am telling you from a high level view. Okay, so there are a lot of things happening behind the scenes. Okay, but if you have to understand it, just understand that, okay, this is your AST. This AST is passed into ignition interpreter. Now the ignition interpreter is converting your AST to the bytecode, and now this bytecode is finally executed, right? That's how the things work. But as I told you that JavaScript is just in time compiled, that means it has a interpreter as well as a compiler. Now, where does compiler comes into picture is compiler's job. Let me just tell you. First of all, let me tell you the cool name of compiler. The name of the cool compiler over here is Turbofan. Isn't it? Isn't it amazing name? There is a Turbofan compiler which works behind the scenes. Now, let me tell you an interesting story about JavaScript. Whenever you run your code, whenever you give your code, first of all, AST is converted, AST is built. Now that AST is given to ignition interpreter, now ignition interpreter starts reading the code line by line and starts converting it into bytecode. Right? That's how ignition interpreter works. Now, when ignition interpreter is doing its job, then what happens? It recognizes some code which is used a lot, right? Suppose there is a function which is used a lot. Suppose there is a variable which is used a lot. Suppose there is a piece of code which is used a lot. It identifies the portion of your code which is executed again and again. Basically, the code which is executed again and again, and then the ignition interpreter tries to give that code to Turbofan compiler so that we can compile and optimize that code so that whenever it runs next time, it just executes very, very fast. Now I know that was a long statement and you would have not understood it. Let me explain you slowly once again. Okay, what happens is you give your code AST is built. Now when AST is being processed by ignition interpreter, so it finds out the code which is repeated a lot. Suppose there is a portion of code which is run again and again, right? There is a chance of optimization in that code. So what happens is in that chance of optimization, it gives that portion of code, and we, you know what it is called? It is called as hot code, right? Basically hot code. So if there is a code which is hot, which can be compiled, so what happens is that is given to turbofan compiler. Right? Now, the turbofan compiler converts that code to optimized machine code. Optimized machine code. What is the job of compiler? I told you, right? What is the job of compiler? What is the job of compiler? I told you. So the job of compiler is to take the code, compile it, and then why? After compilation, the code becomes faster to run. Right? So meanwhile, some portion of the code is interpreted, then whatever the code can be optimized, we call it as hot code. That hot code is given to turbofan compiler. So that turbofan compiler then optimize it to machine level code, and after it is again executed. Right? So let me just repeat it once again in a very fast fashion. So AST is formed from your code that you write, and then it goes to ignition interpreter. Most of the code, right? And a lot of code, it just interprets it and it runs line by line. It is converted to bytecode and then finally executed. Bytecode and execution. But what happens is there is some portion of code which is reused, which is used a lot, and there are chances of optimization. So what it does is that code is given to turbofan compiler, and then with turbofan compiler, optimized machine code is built. Right? Optimized machine code is built, and then finally that optimized machine code is executed. Got it? Now this is how things work. This process is known as optimization also. Right? This process is known as optimization also. Right? Let me just use some other color to represent the name of that process. Okay, let me use a black color. This is also known as optimization. Right? This portion is known as optimization. Now, let me just tell you, suppose if there is a function which you are calling again and again, what it will do is JavaScript will see that, okay, there is chance that I can improve it. I can compile that code and convert it to machine code so that it runs very fast again. Right? And so that way your code is executed even faster. Right? So basically the major drawback of interpreter was that it was not able to execute the code that fast. But now suppose there are portions of code that needs to be executed that fast, and these are being executed again and again. It offloads that to turbofan compiler, and then compiler actually optimize that code, and then that machine code is read. Now, while in this process, there are chances that you might have to de-optimize the code also. What do you mean by de-optimization? Now listen to me very carefully. What happens is sometimes your code is also de-optimized, right? De-optimized. What do you mean by de-optimized? So this de-optimization is, now let me take an example and show it to you. It's a very tricky concept to explain, right? So suppose in JavaScript, suppose you have let me just give you an example. Listen to me very carefully, otherwise you won't understand. Suppose you have a function sum, and that function sum takes a and b, and it calculates the sum of two numbers, right? Returns sum of two numbers. Right? And this sum function is called again and again. It is called again and again. Now JavaScript sees that, okay, this function is a very hot piece of code, this function. Now turbofan compiler will take that sum function and it will optimize it. But while optimizing the code, turbofan makes assumptions. How? I'll tell you. Makes assumptions. Suppose you call the sum function with 10, 5. Suppose you called this sum function with two parameters 10 and 5. So what happens is turbofan compiler will assume that the value of a and b will be numbers, and it will optimize the code. So next time you make a call, suppose you make a call to sum 2 comma 3. So what happens is this will be running very fast, right? This code will be compiled, right? This code will be compiled. This code will run very fast. Suppose if you call the sum once again, with the numbers maybe 6 comma 7. So what happens is that this code will also run very fast. Now suppose you call this sum function. Now this time you did not pass it two integers. Now suppose you did not pass it two numbers, but you passed two strings. Because in JavaScript you can do anything, right? If it is a sum function, you can pass it two numbers, you can pass it two strings, you can even pass a function inside a function, right? So what happens is, suppose you passed in two alphabets. Suppose I say, okay, sum of A and B. Okay, so basically when you sum two strings over here, so it basically concatenates the two string, right? Suppose you do a sum of A and B, so it will make AB, right? This is how it will happen. So suppose if you do this, now here the optimization fails because Turbofan has compiled your sum function to be executed for two numbers. But now it is not seeing a number, it is seeing two strings. So what it says that, okay, whatever the code that I optimized is not correct. Because I was expecting an integer, I was expecting a number, but what came in? Strings came in. So what it will do, it will de-optimize the code, and then the ignition interpreter will again call the sum function A and B with two strings, and it will convert it to bytecode and will do execution. So do you understand that or not? Okay, let me just explain you once again. So what happens is, suppose there is a sum function. Okay, suppose there is a sum function A comma B. Now what happens is, this calculates the sum of A and B. Okay, this calculates the sum of A and B. Okay, now suppose if you gave sum of 10 comma 7. Okay, so this code will run. Suppose if you wrote sum of 7 comma 6, you passed in two integers again. So what it will do, the ignition interpreter will recognize that, okay, this sum function is being called again and again. That means we can optimize it so that next time it runs, it will be very fast. So the Turbofan compiler tries to compile that code and optimize it. But while making an optimized version of that code, it makes some assumptions. And those assumptions are that, okay, these two values will be numbers. So it generally makes the assumption of the types. So suppose it says that, okay, sum function will also take two numbers, right? But if you will keep passing in numbers over here, if you will keep calling this these two statements, right? So it will execute very fast. But as soon as you start passing in some other things, suppose if you start passing in objects, where the Turbofan compiler was expecting numbers. So what will happen now? The code will be de-optimized. So JavaScript engine is recognizes that, okay, now the code that I optimized will not work for some function anymore. I need to de-optimize it. Basically, the Turbofan compiler will say, I cannot send the request to optimize machine code because this will not work, because there are no numbers out there, right? So it will again de-optimize the code. Now ignition interpreter will again interpret it like how it used to do, and it will take that and it will convert to the bytecode and execute it. So while the code is running, a lot of things are happening. So ignition interpreter is interpreting your code again and again. It is just checking whatever codes can be optimized. That hot code is passed to Turbofan compiler. Now Turbofan compiler is making a machine optimized code. Machine optimized code is then executed. In the ignition interpreter is also executing the code. Now if suppose some code it needs to be de-optimized, it de-optimizes also. And when it de-optimizes, then ignition interpreter again converts it to bytecode and executes it. So all these things are happening in parallel. All these things are happening in parallel, my dear friends. And meanwhile, there are a lot more things happening, right? There is one more thing which is known as inline caching. Read it up, right? I am not explaining everything because it becomes very tough for me also. There is something known as inline caching, okay? There is something known as inline inline caching. Okay, so it caches things up, and then there is something known as copy elision. So there are a lot more thing, caching, right? Inline caching, copy elision, all these things are happening behind the scenes inside this ignition interpreter, compiler, and all these things, right? And this whole thing, what you see over here, is known as just-in-time compilation. Okay, this whole thing is known as just-in-time compilation. Basically, the use of compiler plus interpreter to convert the code to bytecode and machine code and then finally executing it. The whole process is known as this whole process is known as just-in-time compilation. So you understood, right? JavaScript is neither an interpreted language, neither a compiled language. It uses interpreter as well as a compiler. It uses the power of both. Right? That is why you see, right? As soon as you give JavaScript to V8 engine, it just quickly executes it. How? How does it quickly executes it? Because of ignition interpreter. Right? Interpreter starts reading the code line by line very fast, right? Now, as soon as it sees the opportunity to optimize, it passes that code to Turbofan compiler. Turbofan compiler then optimizes the machine code and then it optimizes it, right? Now, next time that code is executed, it executes very fast. Very fast it is executed. Isn't it amazing? Right? The power of interpreter plus the power of compiler. Now, suppose if the Turbofan compiler sees something unexpected, then it de-optimizes the code also. Think about the beauty inside V8 engine. Somebody has written a code to do all these things. Somebody has written code to implement whatever. I am showing it to you in the diagram. It looks easy, but it is not easy, my dear friends. It's a very, 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 very complex thing. It's a very complex thing. Inside, internally, I have not even explained you, right? If you go inside, then you will see that, okay, there are a lot more level of complexities involved. I have just given you a very easy example of a sum function over here. Right? So what do you see as a developer is, suppose if you are building a function, then suppose if you are passing two integers, so always pass the expected things. Always pass expected things. Suppose if you have a function, sometimes you pass in integers, sometimes you pass in strings, sometimes you pass it something else. So what happens is, it takes a tough time. It is a tough time for a compiler. You understood, right? Now, as a developer, if you create a sum function, you should only pass numbers if you want to pass numbers. Don't pass strings over there. If you start passing in strings, then what will happen? The compiler will have to de-optimize the code. Optimize it, de-optimize it, and it will take more time than it is expected. Now, let me just recap everything once again in another diagram. Let me make everything once again, right? So let me just summarize everything. Suppose you have this code, okay? So you have a code over here and you pass this code to V8 engine. So the first thing happens is what? You know, right? Parsing. Parsing happens, and inside the parsing, it is broken down into tokens. Right? It is broken down into tokens, and then after tokens, what happens is there is a AST generated, isn't it? Do you remember? So the output of parsing phase is AST. Now this AST is then passed to your ignition interpreter. Ignition interpreter, right? And what does this ignition interpreter will do? This ignition interpreter will convert this code to your bytecode, isn't it? Bytecode, which is finally executed. This is execution. Okay, bytecode is finally executed. Now what happens is, in between of this ignition interpreter, if it finds the opportunity to optimize the code, what will it do? It will pass that to Turbofan compiler. Turbofan compiler. This step is over here known as optimization. Okay, and now what will turbofan compiler do? Turbofan compiler will compile this code and convert it to optimized machine code. Optimized machine code. What will happen to optimized machine code? It is finally executed. Now, there is one more step involved which is known as de-optimization, right? This step is known as de-optimization. Let me use some other color pen to highlight it. This is known as optimization. I am trying to make my diagram beautiful, and this is known as de-optimization. Okay, all these things are happening. Now, over here, de-optimization happens, and once the de-optimization happens, right? Once the de-optimization happens, what happens is ignition interpreter again converts it to bytecode and then the code is executed. Now, all this is happening behind the scenes, right? Now, V8 engine also is doing one more important job, and that job is known as garbage collection. Do you know that? Do you remember? There is one more job of V8 engine that is known as garbage collection, right? So there is a garbage collector, there is a garbage collection. Garbage collection. This is a parallel job, right? There is a garbage collector, garbage collection. Okay, let me just make it a little more beautiful in the diagram so that, okay, so this is garbage collection. That is happening simultaneously, my dear friends. This garbage collection is happening simultaneously over here along with running the code, right? Ignition interpreter, turbofan compiler, and garbage collection is happening in parallel by V8 engine. Now, there are different type of garbage collection, which are garbage collectors, which are there in Chrome's V8 engine. The first one is known as Orinoco. Orinoco. Okay, so I told you, right? V8 engine has cool names of things. So just like it has ignition interpreter, turbofan compiler. So the garbage collector is known as Orinoco. There is one more garbage collector, right? Its name is oil pan. Okay, let me just write it properly. Okay, so let me make garbage collection even better. Sorry for my bad handwriting. Garbage collection. Okay, and now that garbage collector first is Orinoco, Orinoco. Orinoco. There is one more garbage collector which is known as oil fan, right? Oil pan. One is known as scavenger, right? And there is something known as, I don't remember the name actually, Mark Compact or MC something, right? MC garbage collector, right? Compact, some Mark Compact, I think, right? So these are the things which are happening inside garbage collection. This garbage collection is happening behind the scenes. There is an algorithm. There is known as mark and sweep algorithm. Mark and sweep algorithm, right? Mark and sweep algorithm which is running behind the scenes. There are so many things that happen V8 engine. Inside V8 engine, there is parsing going on, there is AST being converted, there is ignition interpreter, there is bytecode which is being generated, then it is executed. There is a optimization and de-optimization happening inside the turbofan compiler. And trust me, I love the names. This is ignition interpreter, there is turbofan compiler, there is Orinoco, oil fan, scavenger, something Mark Compact or something. I don't remember the name exactly, but there are different type of garbage collectors which are present over there. They are doing their own job. There is a different job of Orinoco. There is a different job of oil pan. There are new memory spaces which are being vacant. There are old memory spaces which are being cleared, and a lot of things are happening in garbage collection methods. There are different types of algorithms also. This is mark and sweep algorithm. There are more algorithms out there. Even while interpreting and compiling the code, there are caching happening. And if you will see how this code is compiled, then it's again a very big concept in itself. But in this video, my dear friends, my major motive was to, make you curious, make you understand that how beautiful V8 engine is. The code that you write where a is equals to 10, a lot of things are happening behind the scenes. Lot of things. That code is broken down into tokens, then those tokens are converted to AST, that AST goes to the interpreter converts it to bytecode, then bytecode is then executed. So many things are happening, and in between compiler is happening, in between garbage collection is happening. Whenever you run the code, there are so many things that your computer is doing, and it is doing everything in just fraction of seconds. Just doing it a fraction of seconds. That is why I just love JavaScript. I love how V8 engine works. It's very, very beautiful. Very beautiful, my dear friends. Read more about inline caching, how it happens, copy elision. Read more about all these jargons that I told you, right? All these things are very amazing and unique in themselves. This is how the whole V8 engine works, my dear friends. This is how the whole V8 engine works. Hope you would have understood it. Now let me show you some amazing things before we end this video, because I really want to show you, and I also want to give you some references and resources where you can go and read more about everything that I told you. Now a lot of people also ask me, Akshay, where do you read and where do you get all these knowledge? I'll tell you where I get this knowledge. Okay. So now if I go back to the browser, so I showed you astexplorer.net. Now I have opened few tabs over here. So the first tab is to show you that this is the V8 repository, Chrome's V8 repository. And if you will go into the Chrome's V8 repository, if you go to the source over here in the SRC folder, right? Where is the SRC folder? This is the SRC folder. You will find compiler over here. So if you will see over here, here is the compiler. What compiler is this? This is Turbofan compiler. This is the Turbofan compiler. Let me also tell you, before Turbofan, there was a compiler which was known as Crankshaft, right? So now Crankshaft is not used anymore. There was a compiler which was known as Crankshaft. Okay, so let me write it down small. You can read about that also. Earlier there was a compiler which was known as Crankshaft. Okay. Now, so why I am telling you all this? Because see, I have this knowledge because I have read it, right? Crankshaft was removed. Now in latest versions of V8, Crankshaft is no longer used. The new compiler is Turbofan compiler. It has a different way of compiling things, right? So earlier, you know what used to happen? Earlier, there were different processes happening. But when we say, right, that Google is working on to making its JavaScript engine fast, this is what it is doing. It is trying to save even fraction of milliseconds if they can, by optimizing your code as much as you can, right? 10 years ago, when you used to write JavaScript, you used to write the same, where a is equals to 10. Even today you write where a is equals to 10, but now the speed of execution, because of these such amazing V8 engine and JavaScript engines, is amazing. Earlier, 10 years back, the code where a is equals to 10, or any piece of JavaScript code used to run in the same way. The results were same, but the speed of execution have improved drastically, and all the credit goes to amazing JavaScript engine and amazing processing power of computers, right, in our new era. Earlier, people used to hate JavaScript because it was slow. Why it was slow? Because it was interpreting things. It was not compiled. There were so many issues. It was slow. But today, my dear friends, JavaScript is not the same that was 25 years earlier. In 1995, JavaScript was built, and the first JavaScript engine was built, which was built by the creator himself, right? And that engine is now SpiderMonkey. Okay, the SpiderMonkey engine that you have, that is the one which was written long back. Since then, not just the language, but even the engines have evolved, and now we have a capability where JavaScript is very fast. It can be used in servers. Earlier, JavaScript, nobody thought that, okay, JavaScript was a very slow and a heavy language. Nobody knew that, okay, JavaScript can be run on a server also. But after Node.js, these things changed a lot, and JS engines have also made a significant impact in this industry. JS engines also made JavaScript language popular, and all these things are happening very fast inside it. Earlier, JavaScript was an interpreted language. Now it is just-in-time compiled language. Okay, let me tell you one more thing before I show you the code and everything, right? Now, I want to tell you one more thing that, okay, in this, whatever I taught you in this video, right? All this is V8 architecture. V8 architecture and V8 engine only. And let me tell you, my dear friends, I have personally just read about V8 engine, but these things happen very differently in other JS engines. Right? Suppose if there is a JS engine in JS engine SpiderMonkey, right? Things happen very differently. All the companies have written different type of things, but in a nutshell, things are very similar. Okay, in other JavaScript engines also, there will be an compiler, there will be an interpreter, but inside the algorithms, there might be a little different, right? The name of the interpreter or a compiler will be very different. The garbage collection mechanism could be very different. But in a nutshell, if you understand Google's V8 engine architecture, you understand like almost everything. Right? Because V8 engine is the best JavaScript engine out there in the market as of now, and Node.js uses V8 engine behind the scenes. So knowing the architecture of V8 engine works well for you, but for your understanding, I am just telling you that these things can be different, are different in other browsers also. Whatever I am talking about, Ignition interpreter, Turbofan compiler, these things are very specific to Google V8 engine. So just you should know these things also. Otherwise, in your interview, you go and say this, that, okay, Mozilla Firefox, JavaScript engine, SpiderMonkey or other JavaScript engines are also working in the same way. No, that is not the case. This was very specific to V8 Google engine. Now, but at the end of the day, these are the things which are happening behind the scenes. Every JavaScript engine will convert your code, broke it down into tokens. Tokens are converted into AST, and after converting to AST, it is passed on to Ignition interpreter, bytecode, and optimization, de-optimization. All these things work behind the scenes. Okay, now let me just quickly go to code. I know that this video has already become long, but I was trying to make a short video about V8, but again, right, my deep dive videos just go a little more deeper and deeper. I have so much in my head that I wanted to give you as much as possible in a easiest format. If I start to go deep inside Turbofan compiler and how these optimized code work and internals of all this, it is much, much, much more complex than this. There is a whole team, very big tech team, which works on just improving this V8 engine. This V8 engine is just improving version by version. In each version, this V8 engine improves in itself, and our life as a developer is becoming easy. The browsers are becoming very fast. JavaScript is becoming very fast. Node is becoming very fast. And our ecosystem is becoming very fast. We can now use JavaScript in so many amazing places. And one of the major reason is because we have cool JavaScript engines like V8, and all this is open source, my dear friends. If these things were not open source, if there was a company who was charging you to give you V8 engine and all these things, it would not have been, the ecosystem would have not have been evolved a lot, right? That is why JavaScript is very popular now. We have such cool things, and we should be proud as a JavaScript developer ourselves, right? That is why I love the language also. And JavaScript as a language is very unique in itself. It has a very unique history, and it has a very unique ecosystem. See, JavaScript language was, when it was built, nobody knew that it would come so far and it would become very popular. There have been so many languages which are built, computer languages which are built, and they are dumped, right? Now nobody uses them. But JavaScript has stayed so far. It was just by luck or by ecosystem, but it has stayed so far, and there is a reason for it. because the ecosystem is also evolving. JavaScript V8 engine is also evolving. Your libuv is also evolving. Node.js is also evolving. Browsers are also evolving. And there are big companies like Google who are working day and night to build such an amazing engines and all these ecosystem which is supporting JavaScript at a much deeper level. Now you understand why JavaScript is so popular, why Node.js is so popular, and why we are actually making this whole series and loving Node.js so much more. Are you loving Node.js or not? I just want to ask you that question once again. If you are loving Node.js, have you written it on social media? Write it on Twitter that, okay, I love JavaScript, I love Node.js, and tag me along over there. Write it on LinkedIn, share it on Instagram about Node.js. I would love to see and read your post and tell me if you are falling in love with Node.js already or not. Right? My efforts is to just make dive deep videos also so that I can, make you curious also. See, as a developer, I have learned a lot of things just because I am curious. I want to know everything. How, when I first of all saw this diagram, if you will search on the internet V8 architecture diagram, you will find a similar kind of a diagram. I'll show it to you in a while. Okay. You will find similar kind of a diagram. But I was very interested to see that what happens inside parsing. What happens inside Ignition Interpreter? What happens inside Turbofan compiler? If you have this curiosity, you will find questions, you will find answers for it. And those answers will just make your foundation and knowledge deeper and deeper and deeper. You will appreciate that when I write some JavaScript code, that is nothing. There is so beautiful, so amazing code which is working behind the scenes to make our code work. Right? So you should know and appreciate the tools that you use, and I just love it. Right? I just love the whole thing. Right? So if you will see, this is your V8 engine. It's just at the end of the day code. Whatever you saw over here, Ignition Interpreter, Turbofan compiler, optimization, de-optimization, these looks very complex, garbage collection and all. Everything is code at the end of the day. At the end of the day, everything is just code. That is all, right? If you will go over here, this is your compiler, and you would also find an interpreter. Where is interpreter? This is your interpreter, right? If you'll go over here, you will find interpreter, right? All these things over here, right? This is bytecode register, bytecode source info, bytecode traits. Trust me, if you ask me, I also have not read this code. I don't understand this code, but I have read the documentation. That is how I have got to know what happens here, right? I really don't understand it. Some people say that, okay, Akshay, do you understand this code? No. I was teaching this to my students, and some students asked me, Akshay, do you even understand this code, right? Are you familiar with this code? So I honestly tell you, I don't know what is written inside this interpreter, how these things work. I have explored the Node.js code repository. I have not explored the V8 engine code repository much, right? But if you feel free to explore, right? Why not? Go ahead inside there and just use it, right? You will find all sort of things. You will find a compiler over here. You will find an interpreter over here. You will find, see this, you will find these heap, right? Do you see this? This is a heap. I assume that this is a memory heap, right? Where it is allocating memory and all that stuff. Right. I don't actually understand this, but you can go and read about it. This is what I wanted to show you, that everything over here, what is done, right? Whatever I have explained over here is being done by this code repository. You can just go there and execute it. Now, one more thing I wanted to show you is what is bytecode. And how does bytecode look like? I have already shown you, I was excited that, okay, how does bytecode look like, right? So we saw that, okay, AST look like this, right? We know that, okay, if we write this code, this AST is formed. Now, how this AST is processed into bytecode, right? Interpreter is taking this AST and it is converting to bytecode, right? So let me just show you how the bytecode looks like. So if you will go to this place, right? So I have opened it already. So in the V8 engine, there is a test folder. In the test, there is CC test, interpreter, and bytecode expectation. So basically, these are test cases written for interpreter, right? These test cases will make sure that your interpreter is working fine, right? So these are the test cases. And if you will go over there, So over here, if you'll go, you will find all sort of bytecode expectations, right? So suppose if you write a if condition over here, right? So let me just show you one thing, right? Suppose if you're writing a if condition, okay? Suppose if you have a if condition over here, function f, so if 0, return 1, else return -1. Okay, so suppose this is the code that you write. So the bytecode is this. Okay, this is the bytecode at the end of the day, right? So your code is converted to AST. Now AST is converted into a bytecode, something like this. Over here you can find bytecode of a lot of things, right? So see, if you have written this statement, see this, where a is equals to 1, if a plus 1, else return 2. So if you give this type of code, so the bytecode is formed like this. This is the bytecode. This is the bytecode. So do you understand this? Suppose if the code over here that you see is this code, let me just write this code, okay? So what happens is, now I am showing you the actual what is happening over here, right? So in the parsing phase, this code is converted into AST. Okay, let me just see this. This code is converted into AST. See the AST, how the AST looks like, right? This is the AST. Now this AST is passed to ignition interpreter. Now the ignition interpreter will interpret the code, and in that phase it will convert to bytecode. And how that bytecode will look like? This is the bytecode. Okay, this is the bytecode. Now you won't understand this bytecode. Otherwise, I can also go ahead and explain you all these things, but there is no point in explaining all of this because this is again a lot complex, right? Basically, there is a statement which allocates memory, right? Suppose if you are trying to allocate this memory to 1, right? Allocate the value 1 to a memory space. So all these things are written, right? So this where a is equals to 1 is something which we understand, right? The computer understands a very different language, right? So this is the high level code. This is a low level code. And after this code also, the code is converted to machine code, which is much more low level, right? Which is much more closer to the machine, right? And finally, that machine code is converted to binary, right? And the computer basically understands zeros and ones, right? So that's how that whole execution works. As a developer, we don't understand. We just write very high level code, right? JavaScript is a very high level code, right? And then it is converted into bytecode, then it is converted into machine code, and all these bytecode and machine code is finally executed by your computer, right? So that's how things work behind the scenes. Hope some things are making sense. I know this is a complex topic. I would request you to see, I have just planted the seed of curiosity. I just said you, right? I just told you that I just planted a seed of curiosity. Now it's up to you. You go ahead, explore more, read about all these things and increase your knowledge, my dear friends, because I want all the Namaste Note students to be very, 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 very good and make me proud as a teacher. Okay, so go ahead, read this. I'll give you some resources also. So just check. This is the bytecode. It will be available over here. Pause the video and you can go and see this file for if conditions. And you will, let me just show you, right? It is for if condition. I was just showing you the demo. If you suppose you want to see that how the bytecode is generated for a for loop. Okay, there might be something for loop also. Where is it? See this. This is the for loop, right? So for in loop. Right. So suppose if you have this loop for in, where is a for in? See, if you write for in p is null, right? So basically this is the bytecode. Similarly, if you will go over there, this is the bytecode. For what? If you are writing this, where x is equal to potatoes, and if you say that, okay, where p in x, so return p. So this is how the bytecode will look like. So you can go and explore, just try to see. If you are interested, go try to understand the meaning of these lines also, right? You can give this code to ChatGPT, ask it to explain. I hope ChatGPT will be able to explain this thing to you, right? But just try to understand this if you want to, if you are curious enough. But this knowledge is also very important. And let me tell you, my dear friends, this was again an advanced video, advanced episode in this whole series. Most of the Node.js course you will ever take will not be covering all these things, but I as a teacher wanted you, my students, to know all these things, and I just don't want to get my job done and just quickly finish Node.js and go away. No, I want you to become a very good developer. I just don't want you to crack interviews or do something. I want you to be a good developer. That is when me as a teacher will be successful, if my students become successful. I want you to become very good developers, right? I want you to give all the in-depth knowledge that I have, that I can, and that is all the work which I do, right? So this is what is. One more thing is, the best place to read about all whatever I have covered in this video is the V8 blog, right? This is the v8.dev official website. If you will go to V8 official website, you will find everything about everything. Whatever I have talked, whatever I showed you in this diagram, and whatever I have told you in this video, all the knowledge is coming from official website, official blogs, official videos, and most of the content, everything is available on this official V8 website, v8.dev, right? So I have some articles for you. Launching Ignition and Turbofan. See this. In 2017, this article was written which describes about Ignition and Turbofan. And I told you, right, it was a very major breakthrough in the history of V8 engine in 2017 when these things were launched, right? They were launching it. And see this, these were the logo. This is your Ignition interpreter, logo for Ignition, brand new interpreter, and logo for Turbofan, brand new optimizing compiler. It is known as Turbofan optimizing compiler. It optimizes the code. So in 2017, a new V8 version was released, and there was a major change in the algorithms which I explained you right now, right? Everything that I explained you right now started happening in 2017. Before 2017, there was a different type of way how your code was interpreted and read. Okay, so that was a different thing. This is the newest thing. So please read this. Please read this blog. This is a very amazing blog over here, right? Which is present over here. You will get a lot of things, right? Go to these links also. It will explain you what is Ignition, right? See, this is the Ignition interpreter. And read about it. See, V8 features an interpreter called Ignition. Ignition is a fast, low-level, register-based interpreter written using backend of Turbofan, right? Now, this one line is making me so much curious to explain you a lot, but for now, I want to end this video because it has no end. If I start explaining you that what is this low-level registered-based interpreter, this one sentence needs a one video, right? I can go dive deep into all these things also. Maybe I will cover all these things sometimes in my YouTube channel or something. But for this Node.js, Namaste Node.js, I want to rest over here. This is the knowledge which I wanted to give you, one level deeper knowledge that most of the Node.js developers have. Trust me. Most of the Node.js developers which are out there in the market, most of the students don't know about all these things. But I, as a teacher, want all my students to know all these things, right? You should appreciate what is happening behind the scenes. Go read about all these things. Everything that I told you, Ignition interpreter, if you'll go to Turbofan, read about Turbofan, what is Turbofan, how it works behind the scenes. See, high-level overview of Turbofan, read about it, right? See this, right? You will understand how it works. If you give it function X, then how it works. More sophisticated optimizations. You can, what I told you is just a fraction of what it does, right? There are lots of things behind the scenes, right? And then you can also read about other things, right? Firing up the Ignition interpreter, right? And how the Ignition interpreter is increasing the speed using just-in-time compilation. Read about this just-in-time compilation. What is this just-in-time compilation? Right? Read about all these things, right? Go to Wikipedia, whatever resource you find, read more about it. The more you read, the better you will become, the better developer you will be. Okay? So this is what I want you to be. And one more thing I wanted to show you, right? The best place is to go to V8 official website, v8.dev, right? How to go? V8, just write V8 on Google. This is the V8 JavaScript engine official website, go over here and go to the docs page, right? If you'll go to the docs page, you will find all the documentation about everything. You will find all the documentation about everything, right? Over here, if you will see, you will find ignition, turbofan, and all these things over here, right? Whatever is being used. And if you'll go to blog, this blog is also an amazing resource. Whatever I have told you in this whole episode, everything you can find in blog also. If you search over here, if you write oil pan, right, you will find, see this, there is an oil pan garbage collector, right? This is the oil pan. If you write about Orinoco, see this. This is the Orinoco garbage collector. If you click on it, maybe, see this. The name is Trash Talk. Okay, Trash Talk, the Orinoco garbage collector. This was written. This blog was written in 2019, right? So just see this. If you will go and go and watch these videos. These videos are, this is a new V8 garbage collector. This Orinoco is such an amazing thing. Just go and read this blog. Go and try to watch this video. Peter Marshall explains it so well, that how Orinoco works behind the scenes. Why they brought in Orinoco in first place inside V8 engine. How it works behind the scenes. You will find all these things, right? So, see this. There is a major garbage collector. There is a minor garbage collector. So, the minor one is known as scavenger or something. It must be written over here somewhere, right? Is it? Minor. Major is known as, see, what I was telling was mark compact, full mark compact. Okay, this is the major garbage collector. There is a minor garbage collector also that is known as scavenger. See this, scavenging, right? So read about all these things. It's been a long time since I have read this. I also don't fully know about the internals of Orinoco right now. It was, I think, few years back, I was reading more about Orinoco. I was very interested. But I also want you to just read about all these things. There are lot more complex things which are happening, and I find it very interesting. Okay, so I think that this is enough. I feel if you will go through these blogs, if you'll go through these docs, you will have a very crystal clear understanding of how V8 engine works. This was the video of diving deep into the V8 engine. Hope you would have loved it, right? Hope you would have loved it. If I go back to our original diagram, this is the whole Node.js, and Node.js internally works in an amazing way when you give it some code. And I, in this episode, told you how V8 engine works behind the scenes. Okay, in some other episode, in the next episode or in next few episodes, I will be diving deep into this libuv library also. It is also very, 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 very amazing. In libuv library, you will find event loops, you will find a lot of queues, you will find how everything is working behind the scenes, how network calls are being processed, how non-blocking IO works. Everything will be covered in this libuv video. I am super excited to make libuv video also. I have explained you the overall high-level architecture of Node.js in previous episodes. In this episode, I covered V8. In the future episodes, I will cover libuv and a lot more amazing things. Hope you are enjoying this course. If you are enjoying this course, my dear friends, I would request you to please go ahead, go to social media, go to LinkedIn, Twitter. Please spread a word about us over there. That would be a huge help for us. Thank you so much for the people who have already posted about us. Do tag me. You can also share the knowledge that you have learned in this whole video in social media posts. That would help us also grow. Talk about Namaste Node.js to your friends, to your family, to your social media network. And please refer more students to us and tell them, because see, I put a lot of efforts in teaching all these things. These things take a lot of time to prepare all these content and to make all these things, to understand all these things and then put it in a very easy words for you, right? If you will go and try to read it yourself, it will take a lot of time to understand all these things. I have done that hard work for you, and I want you to become a very good developer. That is why I want to give you all the knowledge I have, right? It takes a lot of efforts. Please share about us to a lot more people, and that would mean a lot to us. Thank you so much for watching this video. See you in the next one. Till then, bye-bye. See you. Thank you again for watching it. Bye-bye.